Welcome. In this video, we're going to continue our discussion on higher-order functions by looking at map. We'll break down how map works, and then we'll see it in action. We saw how filter reduced the amount of code we had to write by utilizing generics. In this exercise, we'll be replacing bits of logic with Swift's map function. The map function takes a closure as its single argument. The closure is then executed once for each item in the array, returning an alternative mapped value for that item. Looking at how map is implemented in Swift, we see the following. Like filter, map takes a generic type t. Next, we see the same no-escape decoration that we discussed with filter, along with a parameter named transform, which takes a function that has a generic signature. This function itself takes a type of generator element and returns a generic type of t. Map then returns an array of t, and just like with filter, we see that map has the ability to throw. Now, there's a lot going on in the body of map. For the sake of keeping these videos reasonable in length, I'm going to go ahead and send you to this video's resource page for a detailed breakdown of what's going on here. But for now, let's see map in action. We'll start by replacing some logic in our ViewController's initializeGame method. Here, we have a for-in loop that randomizes cell states on a grid. Let's replace this logic with our own simpler version of map. Open utility.swift and create a new extension on array. We'll name our function custom map. It'll take a function which will transform our cell and then return an array of cell. Of course, this looks much like our filter implementation we wrote earlier. So converting our custom map into a generic map should be familiar. Let's start by exchanging each occurrence of the cell type with the word element. Finally, we'll adjust our for-in loop to handle generic types by removing any references to cell. This should work nicely. Let's utilize this back in our ViewController. We'll remove the original for-in loop and replace it with a call to our custom map function. This works great, and of course we can shorten this to one line if we wanted. The compiler can infer the type for us and will even provide a default variable. We can swap out our custom map for Swift's version of map, and the compiler will be happy. Now, if we look at this code, we haven't really reduced the lines of code written, and we haven't made it any easier to read. This begs the question, was this exchange a good fit in the first place? In addition, why and when should we use map over a for-in loop? Let's take a moment to discuss when we should use map and when we should stick with for-in. Clearly, we don't want to replace all of our loops with map or with filter for that matter. We want to be deliberate when replacing code. In order to understand when to use map, we need to remind ourselves how it operates. Map takes our given closure expression and executes it once for each item in the array, returning a brand new array. While a for-in loop modifies, updates, or just simply accesses values in the original array. With that in mind, I'm going to provide some simple rules that you can choose to adopt if you want. Use map when you need to transform an array. For example, if we have an array of doubles and we want to convert each of them to a string that represents dollars, map is ideal. Use for-in loops when there will be side effects. For instance, when we need to change the value of a nested variable, write to a disk, or update the UI, use a for-in loop. Perhaps updating this bit of logic to use map rather than a for-in loop wasn't ideal. As a matter of fact, given these rules, changing our for-in loops to map becomes a bit more rare in general. This doesn't lend itself well for those aiming for a higher level of abstraction. Fortunately, the Swift team recognized this and introduced yet another higher-order function called for-each. For-each is a much better fit for our situation. Let's replace our map function with for-each. This seems much more appropriate for updating cell states, and if we compare this to our starting point, I think we can see an immediate benefit. Our code is readable and succinct. There are a few more places we can employ higher-order functions. Open your life.swift file, and let's evaluate our evolve method. We've got two more for-in loops that we can switch out for for-each loops. And with that, our evolve method now leans entirely on higher-order functions, while being succinct and readable. In this video, we looked at map. We also discussed when we should utilize it and when we should utilize for each. In the next video, we'll look at flat map and see what distinguishes it from map.